Hi friends, in this video we see the transform related basic problems. Let us see the first problem. Find the z-transform of following sequence. So they gave three sequences. Let us see how to find the z-transform. And the first sequence is x of n is equal to 1, 2, 3, 4 and 5. Right? For this we have to find the z-transform. How to find it? Let us see. We know z-transform equation is x of z, that is equal to n goes to minus infinity to plus infinity x of n z power minus n. Right? So first we have to find the limit of this n, where n starts, where n ends. So here you see x of n they have given, but without arrow mark. If there is no arrow mark, the first sample is n is equal to 0. That is, this is n is equal to 0. This one is n is equal to 1. This one is value of the signal at n is equal to 2. This is n is equal to 3. This is n is equal to 4. That means what? When n is 0, that is, when n is equal to 0, x of 0, the value is 1. When n is equal to 1, that is, x of 1, the value is 2. When n is equal to 2, the value is 2. When n is equal to 3, the value is 4. When n is equal to 4, that is n is equal to 4, x of 4, that is equal to 5. So n varies from 0 to 4 only. So we don't go for minus infinity to plus infinity, we go for n is equal to 0 to 4. X of n, z power minus n. Okay. So here you see first n0. So if you substitute n0, this is x of 0, z power minus 0. Then summation plus then n is equal to 1, so x of 1 z power minus 1. Then summation n is equal to 2, x of 2 z power minus 2 plus x of 3 z power minus 3 plus x of 4 z power minus 4. When n is equal to 4, the sequence stops. Okay, so what is the value? When n is equal to x of 0 is 1, so x of 0 is 1, it is here, right? Z power 0 is 1, x of 1 is 2, z power minus 1, x of 2 is 3, z power minus 2, x of 3 is 4 into z power minus 3 plus x of 4 is 5, sorry, z power minus 4. Okay, so this is what x of z. So it is, so x of z is equal to 1 plus, I simplify it. So 1 plus 2 z power minus 1, z power minus 2, z power minus 3 plus 5 z power minus 1. So this is what z transform. So where this z transform exists, where it doesn't exist, that is given by ROC. So ROC is given by region of convergence. Right? So if you want to find region of convergence, find where this z transform doesn't exist. So here you see it is like 1 plus 2 by z. It is like 2 by z. Z inverse is 1 by z. It is 2 by z square. 4 by z cube. 5 by z power 4. Right? So when you substitute z to 0, the function explodes. What is the meaning? When you substitute x is equal to 0, the function will become infinity. So that means we cannot find the transform. So region of convergence is nothing but where you can find the z transform. Where does z transform exist? But when you substitute x, z is equal to 0, the z transform doesn't exist because the answer is infinity. You cannot find it. So you cannot determine. So ROC is everywhere except z is equal to 0. For all other values, we can find z transform. When you substitute z is 0, the function becomes infinity. X of z becomes infinity. So ROC is everywhere except z is equal to 0. This is the answer. Next problem, same 1, 2, 3, 4, 5, but arrow mark at 3. Okay. Second one, x of n is equal to 1, 2, 3, 4, 5. The arrow mark at 3. I told whenever they give arrow mark, that is n is equal to 0. So it is n0. So it must be n is equal to 1. Right hand side positive, n is equal to 2. So this must be n is equal to minus 1. This must be n is equal to minus 2. So here n starts from minus 2. and ends at +2. So what is my Z transform equation? Z transform equation must be n varies from -2 to +2 x of n z power minus n. And when n is equal to -2, that is x of -2, that is equal to 1. X of -1, that is equal to 2. X of 0, when you substitute n0, x of 0 is 3. X of 1, when you substitute n is equal to 1, it is 4. Right? When you substitute the x is equal to 2, it is 5. Now we substitute n is equal to -2, so x of -2, z power minus n, so it is +2, plus x of -1, z power n is -1, so z power +1, plus x of 0, z power 0, plus x of 1, z power -1, plus x of 2, z power -2. We know the values. Here you see x of -2 is 1 into z square. X of -1, 2 into z power 1. Z power 1 is z. X of 0, 3 into z power 0, 0. Z power 0 is 1. X of 1 is 4, z power -1. X of 2 is 5, z power -2. This is what our x of z. Here we have to find ROC. How can we find ROC? Here you see ROC is, I told where the function explodes, in that location the ROC doesn't exist. So here you see this is like z square, it is like 1 by z square, this is like 1 by z. So what will happen when you substitute z0? This will become infinity. Yes or no? When you substitute z0, 1 by 0 is infinity, or 1 by 0 square infinity. So the function doesn't exist. So z is equal to 0, the function explodes. Similarly, when you substitute z infinity, again the function becomes infinity, because these two values will make the function infinity. So when you substitute z is equal to infinity also, the function explodes. So ROC is everywhere except z is equal to 0 and z is equal to infinity. This is the answer. Okay. What about third problem? X of n is equal to 1, 2, 3, 4, 5. Arrow mark at the end. Okay. So third problem is x of n is equal to 1, 2, 3, 4, 5. Arrow mark at the end. That means what? This is n is equal to 0. Yes or no? So left hand side it is -1. N is equal to -1. N is equal to this -2. N is equal to -3. N is equal to -4. So where n starts, n goes from -4 to 0. So x of z is equal to -4 to 0. N is -4 to 0. X of n, z power -n. So x of -4, z power +4. X of -3, when you substitute -4, it will become +4. Z power 3. X of -2, when you substitute 2, it is z power +2. Similarly, plus x of -1, z power 1, plus x of 0, z power 0 is 1. Okay. So you see x of -4 is 1. X of -3 is 2. X of -2 is 3. So I can write 1 into z power 4 plus 2 into z power 3 plus 3 into z power 2. X of -1, when n is equal to -1, x of -1 is 4. 4 into z power +1. 4 into z power +1 z. 5 into z power 0, 5 only. Z power 0 is 1. So this is what our x of z. Okay. So we found x of z. Now we have to find ROC. Where is ROC? Right? ROC is the point where you can find z transform. But when you substitute z infinity here, what will happen? When you substitute z is equal to infinity, the function explodes, because x of z becomes infinity. So when you substitute z is equal to infinity, the function is infinity. Otherwise, it won't become infinity. That means the function exists. So ROC is everywhere except z is equal to infinity. right? So in this way we can find ROC, right? So here you see the first problem, right? So this is 1, 2, 3, 4, 5. The signal starts from N0. Okay, sorry, please bear with me. So here 1, 2, 3, 4, 5. The signal will be appearing like this because N0. So it will be appearing 1, 2, 3, 4, 5. N0, 1, 2, 3, 4. N x of n. So it is right hand side sequence or exponential, it is growing sequence. So for this sequence, ROC is everywhere except at n z is equal to 0. Similarly, you see it is double side sequence n0. When n0, it is 3, 2, 1, 4, 5. So minus 1, minus 2, 1, 2. So here z is equal, here ROC is everywhere except z is equal to 0 and infinity. Here you see 5, 4, 3, 2, 1, right? 0, minus 1, minus 2, minus 3, minus 4. Here you see ROC is everywhere except at z is equal to infinity. So this you have to keep it in mind, right? This may be useful when you solve some complex problems, right? I hope you understand this concept. If you have any doubt, please ask me in the comment section. I will clarify. Thank you. Hi friends, in this video we see Z transform of basic sequence or basic signal. Let us see Z transform of unit impulse signal. First one, unit impulse signal. Right? So we know that unit impulse signal is defined as del of n is equal to 1 when n is equal to 0. 0 when n is not equal to 0. I want to find the Z transform of unit impulse. So x of z is equal to n goes to minus infinity to go plus infinity, x of n, z power minus n. Here my signal is del of n. So summation n goes to minus infinity to plus infinity. My signal is del of n. So del of n, z power minus n, right? So we see del of n exists at only n is equal to 0. For all other values, it is not existing. So even though my limit varies from n is equal to minus infinity to plus infinity, see, for all values del of n is equal to 0, it exists at only n is equal to 0, right? So I don't need to find x of z for all other values because it is 0. I take only n is equal to 0. So del of 0 and z power minus 0. When n is equal to 0, del of 0 is 1. So 1 into z power 0 is 1. So the answer is 1. Simple. Fine. So this is what Z transform of unit impulse signal. So this is what x of z is equal to 1. So that means what you can find Z transform for everywhere because x of z is always 1. So it doesn't, the ROC is everywhere. Fine. So it never explodes. The function never becomes infinity because it is always 1 only. It never becomes infinity. That means it is existing everywhere. If it becomes infinity, then only it is not existing. So x of z is 1. So ROC is everywhere. You can find Z transform for unit impulse anywhere in the Z plane, right? So that is the meaning. Next, Z transform of unit step signal or unit step sequence. Right, we know unit step sequence is x of n is equal to 1 when n is greater than or equal to 0, 0 when n is less than 0. Right? So for this we will find the transform. So here you see x of z, n varies from minus infinity to plus infinity. So when n varies from minus infinity to plus infinity, here you see for negative n is less than 0 means n negative. For negative n it is 0. So n exists only for positive n because n is greater than 0. So I go from n is equal to 0 to infinity. I don't need minus infinity to plus infinity. So x of n z power minus n. Right? When n goes from 0 to infinity, x of n is 1. For positive n, x of n is 1. They gave. So 1 into z power minus n. Right? So this I can write as n goes to 0 to infinity z power minus 1 over n. So I know one formula, n goes to 0 to infinity, an is 1 by 1 minus a, where mod a must be less than 1. That means it is the region of convergence for this formula. So similarly, it is in a, n goes to 0 to infinity, an format. So I can write as x of z is equal to 1 by 1 minus a instead of a, it is z inverse, where mod z inverse must be less than a. Right? So here an, so mod z inverse must be less than a. Fine? Oh, sorry, z less than 1. Clear or not? So instead of a, here we have z inverse, so here z inverse must be less than 1. So I simplify this, it will be 1 by 1 by 1 minus 1 by z, that is equal to z by z minus 1. Here it is 1 by z is less than 1. This implies mod z is greater than 1. Right? If you bring this z, mod z is greater than 1. So what happens? Z transform of unit step signal is z by z minus 1 with the ROC mod z is greater than 1. This is what ROC. Fine. So because this equation exists only for mod a is less than 1. Similarly, this equation exists for mod z inverse is less than 1. So that is what ROC, where the transform exists. So x of z is equal to z by z minus 1 mod z is greater than 1. So this is the formula procedure to find z transform of unit step signal. Okay, so that's all about this session. Okay, let me go and do some other problem which is in the same way related to this. And the problem is find the z transform of an u of n. Fine. Okay, so an u of n compared to the previous problem, what is the difference? Instead of a, here a is equal to 1. Yes, sir? So if a is equal to 1, we will get previous problem. Right? Let us see. Okay, so what is x of z? X of z is equal to summation n goes to minus infinity to plus infinity x of n z power minus n. Since it is u of n, we know u of n exists only for positive n greater than 0. So for negative n, u of n is 0. Okay, so what I do, I take n goes from 0 to infinity because u of n exists only. X of n is a n u of n. U of n exists only for positive n. For positive n, u of n is equal to 1. Just now only we saw. So we have a n. For n varies from 0 to infinity, u of n is 1. Z power minus n. Right? So what you do? You do some manipulation. A z inverse whole power n. So n I take commonly outside. So again it is a n formula. So summation n goes to 0 to infinity a. That is 1 by 1 minus a z inverse. And what is ROC? A z inverse must be less than 1. That is what the condition I told in the previous problem. So what will happen? X of z is equal to a by z, 1 by 1 minus a by z, that is equal to z by z minus a. 1 by z will come here, so I write this one as a by z less than 1. Z inverse 1 by z. This implies mod a is less than mod z. That is mod z is greater than mod a. Fine. So mod z is greater than mod a. This is what you call z transform of an u of n. So an u of n as a z transform of this one. See, we found u of n z transform. What is that? Z x of z is equal to z by z minus 1. Because why? Because here a is equal to 1. So similarly, we know mod z is greater than 1. Already we found this. Yes or no? Mod z is greater than 1, z by z minus 1. The same problem. Right? So this is the transform of an u of n. We know an u of n You see, a and u of n means we know a must be mod z must be greater than a, right? So next problem. So how can I draw ROC? This is what ROC, right? Mod z must be greater than a. So I have to show ROC in z domain. So how to draw z plane is in x-axis we have real part of z RE. In y plane we have imaginary part of z, right? So let us have z is equal to a circle. This is z is equal to a, right? ROC is mod z should be greater than a. So let me assume this is z plane. Mod z must be greater than a means where it should be, this is a, so it should be greater than a outside. This is what z is greater than a. Whatever be inside, it is z is less than a because the circle is z is equal to a. So this is the ROC. Here you can find this one. Similarly, for unit step sequence, I draw ROC. Where is it? For unit step sequence, ROC is z is equal to 1. ROC must be greater than z is equal to 1. So here you see, this is real z. You have to mention everything. Y-axis is imaginary z. What should be ROC? ROC must be greater than z is equal to 1. Let us assume this is z is equal to 1 circle. So ROC must be greater than z is equal to 1. Okay, so this is what ROC of unit step sequence. Fine. Next one, you see this is an u of n. This an u of n has the transform of z by z minus a mod z is greater than mod a. U of n is positive because it exists for only n greater than 0. That is, it is positive sequence. For positive sequence, ROC is outside the circle. You see, ROC is outside the circle. Outside the circle. Right? So, why it is positive? Because n u of n has value for only n is greater than or equal to 0. Right? Okay. Now we see another one signal. For that we find is the transform x of n is equal to minus an u of minus n minus 1. Right? So here you see u of minus n minus 1 exists for, it is 1 when n is less than or equal to 1 and 0 else. Why? When you substitute n is equal to 1, it will become u of 0. Yes, sir? When you substitute less than or equal to 1 means it will go from 1 to minus infinity. When you substitute n is equal to minus infinity, it will be 1. Yes or no? So when you substitute n is 0, what will happen? U of minus 1 will come, that is equal to 0 we know, because u of minus 1 is 0. Right? Because u of negative value is 0, u of positive is plus infinity. Yes, because I am substituting. You see, when I substitute n is equal to minus 1, the function becomes u of 0. When you substitute n is equal to minus infinity, the function becomes u of plus infinity. So we know u of n exists for 1 when n is greater than 0. That is 0 to infinity only. So when n is minus 1, the bracket term is 0. So no, like this, u of 0 to u of infinity. When n is equal to minus infinity, the bracket term is plus infinity. When you substitute n is equal to minus 1, what will happen? It will become u of plus 1 minus 1, u of 0. Right? So if we substitute n is equal to 0, u of 0 minus 1, u of minus 1, 0. Right? For every u of negative is 0, u of positive is only 1. So when n is equal to minus 1, the u of u becomes positive. When n is equal to minus infinity, the bracket term becomes positive. So here n exists from -1 to -infinity, right? So when you want to find z transform, x of z is equal to n goes to -1 to -infinity, x of n z power minus, right? So that is the thing we must know. Okay, so for n goes to -1 to -infinity, x of n is an, sorry, minus an, right? Minus an, question is minus an. U of n is -n-1 is 1 only. That's what we have done. When n varies from -1 to infinity, u of n is u of -n-1 is 1 only. So 1 into z power minus, right? So I have equation for positive summation only. So I make everything positive. Negative is positive. So this minus will be here. I take n is equal to positive. So n goes to 1 to infinity. That means I multiply every n by -1. So this a power, this will become a power minus 1. Right? This will become z power n because I make every n by -1. So it will become in +1 plus infinity, a power minus n, a power plus n. Fine. So that is equal to minus n goes to 1 to infinity, a power -1, z power 1 into n. Fine. So this one I can write as, you see, I have equation for n goes to 0 to infinity, an 1 by 1 minus n. But here I have equation for n is equal to 1. So what I do, I add 1, subtract 1. So 1 minus 1 plus n goes to 0 to 1 to infinity an. If I'm wrong, can I write like this? What I do, I add +1 minus 1, n goes to 1 to infinity. So this is equal to, when you substitute n 0, it will become a power 0 1. So I add 1 plus summation n goes to 1 to infinity an. That is equal to summation n goes to infinity an. Yes or no? So again this -1 will be there. So what I do, this minus I take outside. Fine. So instead of this, instead of n goes to 0, 1 to infinity, right? I make it as what I do, I keep like this, 1 minus n goes to 0 to infinity, a power -1, z power n. Fine. So now you understand why I am writing like this. So what I did, fine. So here you see, this is what this one. 1 plus n is equal to 1 to infinity, an is n is equal to 0 to infinity an. So what is my, I have, this implies n goes to 1 to infinity an equal to summation n goes to 0 to infinity an minus 1. But here I have 1 minus 1. So instead of this, I can write this. N goes to infinity, I can write as n goes to 0 to infinity an minus 1. But if I multiply this factor with -1, right, this will become 1 minus n goes to 0 to infinity an, because I have 1 minus here. So it will become 1 minus n goes to 0 to infinity minus a inverse z power 1, right? Okay. So now the problem becomes simple. So now what I do, 1 minus, yeah, so this is an formula. Right, so that I can write as 1 by 1 minus a inverse z. Fine. So simplify it. So it is equal to 1 minus a inverse z. This I bring this side, -1 divided by 1 minus a inverse z. Fine. So that is equal to minus A inverse Z divided by 1 minus A inverse Z. Fine. So everywhere I take outside A inverse Z divided by A inverse. I take minus A inverse outside. So it will become Z by minus A. A inverse outside minus A inverse I take outside means it will become Z. So A inverse into A, what will become? It is 1, minus 1 will be there. So when you multiply minus 1 plus 1 will be there. So when you take minus A inverse, it will be like this. So everything will be cancelled. So Z by Z minus A, X of Z. Clear? So this is the answer. Fine. Now ROC we have to find. What is ROC? See, A inverse, AN should be less than 1. So here A inverse, for general equation, summation n goes to 0 to infinity, AN means A should be less than 1. Here A inverse Z should be less than 1. So ROC I want to find. Mod A inverse Z must be less than 1. This implies mod Z by A is less than 1. A inverse is 1 by A. Mod Z must be less than mod E. Right? So ROC is mod Z is less than mod A for this sequence. What is the nature of sequence? It is minus AN, U of minus N, minus 1. Where this sequence exists, we know it is existing from minus 1 to minus infinity. Right or not? So this is negative going sequence. Left hand side, it is minus 1 to minus infinity. For that, how ROC will be there? You see, I draw a diagram. Fine, so it is like this, right? It is A, this is real part of Z plane, this is imaginary part of Z. But they are telling Z must be less than A. It is A, less than A means inside. So ROC must be inside. Right, so here inside the circle you can find Z transform for minus AN U of minus N minus 1. Outside you cannot find. The ROC exists inside the circle. So first we saw for right hand side sequence mod Z is greater than mod A outside the circle. For left hand side sequence mod Z must be less than mod A. Right? So that is the difference. I hope you understand everything clearly. If you have any doubt, please ask me in comment section. I will clarify. Thank you.